So far, everyone's been from Ontario. Oh, Judy Black, hello.
Alrighty, let's get going.
Time is X minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All right, welcome everybody. As you can see, we've increased our production values for this series. So thanks everybody for joining us. Welcome to the Moon at Noon. You may know John and I already. I am the outreach coordinator at the Royal Astronomical Society of Canada's national office. John is many things, an author, a dad who had a son recently, and also a Rask Halifax member. And we also have a new guest with us today, Samantha. Everybody say hi, Samantha.
Hello.
Is our outreach assistant at the national office and is a member in Kitchener-Waterloo.
Yeah.
Yeah. So, hello to everyone who's joining in the chat. Thank you all for sharing where you're from. Happy April 1st. And we're going to get started with our first episode of the Moon at Noon today. Please join us with your lunches if you'd like. We aren't bringing ours, but we recommend that you bring yours over your lunch break if it suits your time zone. We started this program after John and I ran Explore the Universe back last year, which we really enjoyed running. It was great to meet everybody who was joining us, and it was so fun to observe with you all. And so we wanted to do it again, this time with a target that was a little bit more accessible to people. And the moon can be seen anywhere in the world, more or less, by anyone, even if you're in the city, even if it's light polluted, as long as there's no clouds, everyone can see the moon. So we wanted to find a target that worked for everybody. So we will be following along with Rask's Explore the Moon program. The Explore the Moon program was developed for the most part by Dave Chapman, who is in the chat. And one of the observing books we'll get into the resources that you can use for it in a minute. If you have any questions about the program that we don't answer as we go along, you can try throwing them in the chat and Dave may be able to answer them as well. The program goes over, I'm going to share my screen just to give you an idea of, perhaps I should bring up the window that I need first. I'm going to share my screen with the overview of the different programs. And so this is the Moon at Noon page where we will find every single resource that we talk about during this show. It's rask.ca/moon at noon. I'll throw it in the chat in a minute. It has our schedule for the topics. It has all the resources that you'll need at the bottom, as well as the guides in particular that we'll be following. Those two guides, one's for binoculars, one's for telescopes. You can do either. We're going to be doing both. So we will identify which targets are binocular targets. All the targets we will do will be telescope targets, but several of them will be binocular targets as well. And you can get certificates for either, but if you want a pin, which seems to be like true Rask gold, so what everybody wants is the pin.
Yeah.
Then that's you have to do the telescope program for. John, you just completed some of this, didn't you?
I did, yeah. So I'll get the pin and I'll add it to my Tilly hat that I wear at all the Rask events.
Okay, Dad.
So, yeah.
So the two books here have every detail that you need to know. We'll be going through them sequentially with you. So if you don't want to read these, technically speaking, you can just rely on us to relay the information to you. It has a detailed picture of everything that's on the moon. Incidentally, this map is actually mirrored in, oh no, my background, the Observer's Handbook. There we go, 2021. So if you're looking for a good map to have around that's handy, I personally like this one. It's a good list. It has the list of all the targets that you need to observe, which is very, very helpful.
Yep. And I use that. I thought that was the best way to go through the program, is using that map, because it only has the craters that you need to pay attention to on it. And it was good so that as I was going through the program, I didn't miss any. So you just sort of, north to south in slices like an orange through it, and we'll talk about all that. but it just made it really easy.
That is the nice part, is that Explore the Moon is based on this map.
Mhm.
So that's super helpful. Dave's saying that your application might have been a bit funny there, John.
Uh-oh.
Hieroglyphic
'Cause your-
interpreter.
Your handwriting might be maybe not the most perfect. So we'll be going through the program step by step on each day with what we're looking for targets. Today, there are no targets to look for because we're starting easy. We just want you to get familiar with the moon and what it looks like if you haven't yet. So the way this program is set up takes a little bit of getting used to. It uses a system called Q days, and Q days are days away from the quarter moon. So looking at, and John and Samantha, you can jump in anytime if you want to, looking at sort of the general order of the phases of the moon, it goes from new, waxing as it gets bigger, through to the first quarter, which is here. Quarters are when the line between light and dark goes right through the middle of the moon, up to full, and then to the next third quarter, again, line right in the middle, and then back to new.
Yeah, and just point out that is a fictional month.
Yes, this is
It
a
just
fictional-
happens to start on the new moon.
Yeah.
This is not now.
This is solely for the pictures, not for the rest of the calendar. Very good point, John. Thank you. So all of the observations in this guide, and as we'll be doing them, are based on days before or after the quarter. So a lot of people are more used to seeing that like new quarter, full quarter, new cycle. And this focuses on those quarter days. This being Q0, so the quarter day, this being a day before Q0, 2 days before Q0, so on and so forth in both directions. And that means that you have 2 opportunities each month to see the targets. You have between the new moon and the full moon, which is first quarter times or waxing. You have from the full moon to the new moon on the other end, which is waning.
I'm just gonna stay up much later at night to do it on the other side.
That's the problem.
Or get up really early.
Yeah. So these moons in the first quarter are quote easier because, as you may notice, in these phases, you see them right after sunset. Especially these, you'll be seeing them like right as the sun goes down, which is a perfectly reasonable time to be awake. These phases you see after the sun has gone down, and as you work into things like summer, that's really late at night, which makes it harder. These phases are somewhat easier if you're an early riser because you can get up at 6 a.m. and see them just before sunrise. But these phases are a little bit trickier. We're going to be doing observations from both phases, bearing in mind that when you go out and observe, it's going to be very weather dependent. And depending on where you are, and you can also go out and observe anytime because these all repeat every 29.5 days. So there's lots of opportunities.
I see some questions in the chat exactly how the Q days work. Like the days, I have a few like just picture diagrams of what you can see.
Yeah.
If you want me to quickly share those. Like
Sure.
we're on, what Q day are we on right now? Q day -2?
We're just after the full moon, so it'd be like Q day -4-ish on the waning phase. Bearing in mind also that all these photos, if you want to see exactly what the moon looks like on any Q day, Samantha has made all of these with all the targets in every view that show you exactly what the moon's going to look like and what targets are visible. So
Amazing
amount of work. Big round of applause.
Are those the photos you wanted to show, Samantha?
I just have
I'll switch to sharing for you if you want to.
these ones, which I forgot to post up. So like we're talking about, so the third quarter or a quarter will be Q day 0. So you can see exactly half the moon. That's the colored part versus like the third quarter +6, Q day +6, you can only see this tiny sliver of the moon. So that's kind of what we're talking about when we talk about Q days, of exactly how much you can see.
It takes some time to get used to Q days because they are people don't normally think that way. They're accurate in terms of how you can see, like what you can see at that time. And it helps you to sort out those like slivers of the moon that you're looking for, like John described. So what we're going to do as we go through this course is when we do a Q day, we will tell you what day of the week and what date that is to go out and observe within the next session. So it's less, you'll pick it up as you go along, but we'll start with that sort of like telling you exactly when to go and look at whichever objects are up in the sky. On that note, Samantha, do you want to expand on why we care about the line on the moon between dark and light?
Sure. So when we are looking for targets, we really want to look right at that terminator location, which is the line on the moon. As you can see right here, you can see the line, how it transitions from light to dark. And the craters are really much more defined right along that terminator, the dark line, because that's where the shadows are cast. So now when we're looking for things on the moon, for craters specifically on the moon, we're looking for the defined features, and those casting shadows allows us to see those features. So that's why the terminator location or that dark line location is really important to us, and especially what craters we're looking at. And that's why we're breaking it down that way for you, because you can't really see all craters any time of the month.
Mm-hmm.
Yeah.
I have a photo to help with this as well, this is a photo I took with my cell phone. Actually, all of our backgrounds are photos that we took with our cell phones through telescopes. This is one of them. And so I held my phone up to the telescope viewpoint. So you can see this crater here, which I'm pretty sure is Archimedes, is really well defined. There's a ton of craters here, but you can't see any of them because the light is shining directly on them. So being able to see those shadows, and there's Cassendi, which we'll get into all this stuff later, because these are targets that you're going to have to go out and take a look at, or you may want to go and take a look at, hopefully. So we'll get into the specific targets, but for now you can see how that detail is increased over here and not in the middle. Alrighty, quick question from Joanne I noticed in the Q&A. Is new moon day 0 or day 1? And here's where it gets confusing compared to what most people expect. Because normally you look at a moon cycle that's 28 days, right? Or 29 days. And you go from day 1 to day 2 to day 3, et cetera, et cetera. New moon and full moon are actually technically Q day 7 or -7. There are days when we can't see anything on the moon, or that's not exactly true. New moons, you can't see anything on the moon because the moon is right beside the sun. But on full moons, there are no shadows to look at. So you're looking at like the entire moon, bigger features like Maria.
Yeah.
And on that note, John, you want to talk about Maria?
Yeah, we talk about Maria. So Maria are the darker colors on the surface of the moon. And Maria means lakes in Latin. So I guess early lunar observers thought, hey, maybe there are lakes on the moon. We now know it's not. It's just a type of rock that is darker colored than the other rock on the moons, or than the highlands. So the Maria are formed from just lava flows or lava bubbling up from underneath during crater hits. So the moon, at least it used to be, molten and with a thin crust. And so when it got hit, stuff would bubble up. There's actually almost no Maria on the far side of the moon. And one of the main theories to why that is because of the crust on the other side of the moon might have been thicker. So the lava didn't have a chance to, bubble up when impacts occurred. One theory. So the lava would have covered up some of the other craters, leaving a more smooth surface area. So that's why, for example, when Apollo 11 landed, they chose a Maria as the landing spot, Sea of Tranquility. And so anything else to add, Samantha?
I guess I was going to ask you, I made all the maps, but why are they named the way they're named? They have some like Tranquillus and Serenity and...
Yeah, so the names for the seas are based on how the ocean might make you feel or states of the sea. So like, it can be stormy, rainy, tranquil, serenus.
Serene's the word.
Serene. So that's where they get their name. So like basically the way that the ocean can make you feel are sort of like states of the sea.
There's
'Cause,
also
you know, like-
bays too, and
Yeah, so
versus
you
seas
might
versus
have,
mare.
I'm gonna share Mare Serenitatis, which is the serene sea, which it does look kind of serene. It's like very peaceful, not much going on in it. I could see that.
Let's go vacation on the moon by the mare.
yeah, so based on the size of those dark patches, you'll have different names. Like some of them will be lakes or bays, or of course with the Latin name for that.
Mhm.
But
I wanted to see if I could find Plato in here. So there it is. So there's Mare Frigoris, which I don't even, was that cold sea or something?
Yep. Too cold.
And so I don't know if it makes you feel cold, but I wanted to mention with Plato, it was a crater, but here you can really clearly see where that like lava that John was talking about came up into it, because this looks a heck of a lot like this. And so at some point that crater formed, or there was a big asteroid that went boom and left a big hole, and then the
So you would
goo-
call it a flooded crater.
flooded crater, yeah.
Yeah. So other craters have a central peak, and sometimes you'll have one with a central peak that gets flooded. You'll have a little small peak in the middle.
Little
But
loop in the middle. I think so. There's one with a little peak in the middle.
Yep.
Mm.
Yeah.
which is just a function of the energy of the impact.
And there's one of the more famous ones. So on the note of this being Tycho as well, there was a question in the Q&A about whether or not you have to observe targets on their Q day, and you do not. The reason it's set up with Q days is because it's easier to see the targets those days, because those shadows add dimension to whatever is there, but you don't have to. You can observe them anytime. I know someone who managed to get like all the targets in a 2-week period, even with clouds in the way, because he observed a lot of them on the brighter days. They're just harder to find.
Yeah, you can also, I got a lot of mine a little bit of ahead of time, just because they were really on that terminator, not, a couple degrees off from it.
Mm-hmm.
So there's definitely some wiggle room there in terms of still the ideal day to see something, but, not exactly on that Q day.
Mm-hmm.
And sometimes the terminator kind of shifts depending on the month, right? So sometimes when I was doing the maps, I noticed that one Q day, you're supposed to see an object on that day, but it was half cut off or mostly in the shadows. So you might not be able to see it that exact day.
And here's the
The
problem.
angle that the terminator cuts the moon is not the same every month. It rotates based on, other factors that we'll talk about later, like libration, which is where the moon rocks from side to side from our perspective, and up and down as well. So we actually see 56% of the surface, not just 50%, even though it's tidally locked. Yeah.
So there's some stuff that's on the more advanced side, and we're going to dive into some of this stuff in future episodes, as John said. So like libration and being able to like see things that are maybe not necessarily in Explore the Moon, but are really cool to see, like that stuff that's right on the edge when the moon is librating. We're going to get into that detail later. We made these only a half hour long because later in the series, we don't have as much to talk about, but today we have a ton to talk about. So we may go a little bit over time today. Sorry, everybody. If we do, this is up on YouTube and you can watch it anytime. There was one more. Oh, I wanted to mention some tools that we can use to help with this. And I brought it up quickly before stopping sharing my screen. This is, and just a heads up that everything that we're showing you, and I noticed Joanne asking this in the chat. Hi, Joanne. Is this stuff up on the website? And it is. I have clicked away from everything, but all of the pages are on ras.ca/moon@noon. Is that here? Okay, I don't know where it's gone. They're all on ras.ca/moon@noon at the bottom, everything that we show you. So this tells you exactly what the moon's going to look like at any time. So this is super, super helpful for planning your observing. If those Q days are off a little bit, the tricky part with the moon in general is that its schedule is not based on our days exactly. And like as hours change, like any given moment, if we say go out and look at this tonight at 10, that's going to be different for people in Halifax versus Vancouver. There's going to be 4 hours of difference, 4 hours of difference between the two. So the light will have moved a bit between Halifax and Vancouver at 10 p.m. So no matter how detailed we get with exactly what time it is where you are, things will change a little bit here and there. So you can go and see exactly what the moon's going to look like at any particular time. So for example, this is today at UT hour 16, and UT is universal time. You can convert that depending on your time zone. I think it's plus 4 hours from Toronto. 15, 14, 15, 12. Yes. So this is exactly now at around 12 p.m. Universal time, or sorry, Canada time, 1600 Universal time. But we can't actually see the moon right now. So this is for people who would be in like, maybe in Asia, might be able to see this right now. The moon's not up here. So if we wanted to see it when the moon's up here, we'd be looking at like maybe tomorrow at like 1 a.m. So that's what it would look like tonight at 12, 11, 10, 9 p.m. here. So you can dial it in based on time zones. The time zones are not super, it takes a little while to get used to the time zones. Some astronomers are used to them. Some haven't had the chance to get used to them yet. Tonight, you would be able to see these craters fairly easily, even though they're fairly well away from the Terminator, for example. And you got some nice ones along here that you can see. But we're not going to get into specific targets this time around because we have enough for that later. We just want intro stuff for the moon. So definitely give this a try. The other app I'll shout out to quickly is Astrospheric, which tells you based on where you are, what the weather's going to look like, when the moon's coming up, when the ISS is coming by, what the wind is, what the temperature is. It's a lot of information, but I find the moon helpful. It does tell you the moon phase in terms of percent illuminated, not in terms of Q days. But you can kind of see the similarities. John has another life hack.
The way I do it is really complicated. I just say, hey Siri, what's the weather? Or hey Siri, what's the current moon phase? Or hey, when's the next full moon? And I don't bother with any of the apps or anything. I just ask Siri or Alexa, depending on what room of the house I'm in.
John's living his best life.
No, but it works. I mean, those apps will tell you what the phase of the moon is, and for most of my weather, I just use the weather app on my phone to know whether it's clear or not, and it's pretty conservative. So, yeah.
All these resources for people who are coming in late, it's ras.ca/moon@noon. Everything we're talking about will be linked there. We've had a couple questions about that in the chat and the Q&A.
I just posted the link to the main website in the chat. I apologize because usually I am good enough at this to post all the links in the chat as we go. But we have a lot to talk about today. So today is not a good day for that. So in terms of, since we have technically 7 minutes left, are we comfortable talking about how to apply once we get to the point of applying and what you need to do in order to apply and all that sort of stuff?
Sure.
So John did this most recently. I can do my best. Essentially what you need to do is same sort of stuff that we did for Explore the Universe, if you joined us for that, which is date, time, what you're using to look at the sky, a description of the object, and if you want, I don't think it's necessary, but if you want to, conditions outside as well.
Yeah. I mean, so basically to get the certificate, you need to observe all the listed targets. So it's basically, there's 3 pages of targets. So you can print this out or just, I have the booklet. So like 1, 2, 3. So there's all the targets you need to observe. They're also all on these maps. So all those targets are just listed right here. And then basically after you've observed those items, you fill out a form and send it to your local observation chair. And then the way that I chose to record my observations, and like Jenna said, you want to record the date and the time and the weather if you want. Where is it here? Yeah, you can print these out too. So there's just a little box so that you don't miss anything like date and time, a description of which targets you've looked at, and then a place to do a little sketch of those targets. So basically my approach was just to use that moon map that just had the craters. And then I drew them as I observed through the telescope. Mm-hmm. And then I went and wrote the names of the craters in off the list. And so that, yeah, must you do sketches? I don't think it's a requirement, but it really helps you appreciate what you're looking at. And as Dave says, you don't have to, but we like it.
Yeah.
I'm not the best. I've never sketched anything on the moon. For people's context, I am a very new observer and I am kind of going through this program with you guys. How do I even sketch something? Like, how do I even go about doing this?
John made fun of me for this. Yeah, look at John's. John's are
so-
great. John
So
did a good job.
basically I do a circle for the crater first after I found it, and then I shade in whatever shade it on it. And the other thing that helps you, if you sketch it and you sketch the nearby targets around it, it makes it much easier to go back and cross-reference to make sure that that target is the right target. Yeah, Dave Dave says he says I've done the minimum there in the comments.
It's minimalist. It is.
This is very, very minimalist, but my understanding, Dave, is that that's acceptable. He would be happier if your drawings were nicer, apparently.
Oh my goodness, I love it. It's just like do the bare minimum, but it's acceptable. Honestly, in this case, it's meant to be fun, right? Like it's meant to be fun.
Yeah.
You're meant to be having a good time. If you hate sketching, if you despise sketching, don't do it. Write down what you saw instead. I like to put a little bit more effort in the sketching, but I also have a harder time. So I spend way more time sitting around going, why am I not good at this? So I like John's approach because it's just like, do enough so that you know what you're looking at. And John also uses like a bigger area of the moon than I do to sketch stuff. I usually focus in like super close on a single crater. And
Yeah.
it takes too long.
Well, one of the things I also did in preparing for this this session is I used a beginner telescope to do my observations. So I have a bunch of fancy telescopes, but I used a telescope even much smaller than this one. So I used a 70 millimeter on a rickety EQ mount just so that I could understand, what other people might be going through if they only have a department store telescope. And so I didn't use anything over 53x magnification. So I used like a 26 millimeter eyepiece and a Barlow, and that's as much as I zoomed in. So I didn't actually have enough magnification to get a lot of detail in those craters, like I might have had I used a bigger telescope, even something like this.
Mm-hmm. And you don't need that detail. I will mention as well with the difference between explore the moon with the binoculars and explore the moon with the telescope. Explore the moon with binoculars is quite a bit harder, and you need fairly big binoculars to do it. Like I would recommend like 10 times magnification, hopefully with a tripod.
Yes, with a tripod. I've tried to look at the moon, and I don't know how you would do it without holding it and then trying to refine your target.
Yeah, that's the hard part. And then for a telescope, you can use anything, like John said, any of like the super basic scopes to more advanced scopes. Ron Fisher's question, can you use a go-to mount for it? I mean, technically speaking, I suppose you could keep it tracked, but I don't think go-to mounts have that sort of granularity to see specific craters on the moon. Like, I don't think you can input craters as a place for your telescope to go to. Can you, John?
No, it'll just stay tracked.
Yeah, it'll just stay tracked. So technically you can use a go-to mount, but it won't help that much other than it'll keep it tracking, which is
so I definitely found, so I used an EQ mount, which means that I only had to turn a little knob to keep it tracking. If I were to use this one, between every sketch, I'd have to go boop, boop, doot, 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 which can get annoying. So I didn't, because I was using this cheap mount, because it was equatorially mounted, it made it easier between, I'd sketch for a minute and then twist it and then sketch and then twist.
Mm-hmm. That helps, and for sure.
Somebody asked about moon filters. Do we have to have a moon filter to be able to view things?
You definitely don't. But moon filters help with contrast because they're basically polarizing filters, and the moon is reflected sunlight. And so reflected light is polarized. And that means that your contrast is going to be a lot better and the brightness is going to be dimmed down. So you may be able to see more detail on craters that are further from the terminator with one of those polarizing moon filters. And that's basically the science behind it, but
life hack, if you don't have a moon filter, wear polarized sunglasses.
Oh,
right.
Yeah.
I got a pair of those. I can do that.
Yeah.
Yeah. And someone asked if you have to be a RAS member. I mean, you don't need to be a RAS member to do it. You need to be a RAS member to get the certificate.
Yeah. And the pin. So if you don't, with Explore the Universe, that was something that was open to everybody, regardless of RASC member or not. So you can have a pin even if you've never joined the RASC. But for this program, you do have to be a RASC member to get the pin and the certification. But if you don't want to join, we understand. We're sad, but we understand. And we will take it personally, but we understand. But if you don't want to join, or if you can't join, then you can still participate in the program. You just won't be able to get that pin and certificate. Wrapping up a few more questions. Is there a time limit to finish it? Nope, you can do it whenever you want. If now doesn't work, if the weather doesn't work for you now, if you want to come back and do it later, all these videos will be rewatchable as well, because all you have to do is find the Q day that you want to observe on. Mm-hmm. And then for people in the US or anyone who is a national member, you can apply through the website, and through emailing the observing chair. We'll have that detail on the webpage, rask.ca/moon@noon, when we do get to applying. For those of you at centers, you can apply to your observing chairs, or to Dave, who is in the chat.
Yep.
And
all right.
yes,
and we're at time now, but did you want to do a brief, because people over, at least in the next week, might start attempting to observe. So there's a few things they're going to need to keep in mind. Did you want to start talking about that?
Yeah, so for this next week, just a heads up at the moment, based on that, hold on, let me share the screen again. Based on that look we had at what the moon looks like tonight, this phase, yeah. And this is a binocular view, so this is what you would see if you're just standing on the ground looking at the moon with no telescope.
From the Northern Hemisphere.
From the Northern Hemisphere. Yep. Sorry to shout out to all you in the Southern Hemisphere, if we have any. It'll be reversed. The left side of the moon, if it's lit up, the moon's getting smaller. So this terminator is coming across from the east side of the moon to the west side of the moon.
Yeah, but the moon doesn't rise tonight until midnight, around midnight. So
that's the issue. So when it's in this phase, it's not up until later in the evening.
And then the next night, it's going to be 40 or 50 minutes later, and so on. So
yeah, and you'll see it getting closer and closer to quarter moon. Quarter moon's about on the 5th, the 4th in the evening. For us, but all of that won't rise until like 2 a.m.
But so for the next cycle, when you guys start really taking it seriously and getting out there with a small telescope and observing, you need to match the map you're using to the type of telescope that you're using. So that's going to be really important. Okay. If your telescope does a mirror reversed and you're trying to use sort of binocular view or regular view map, it's going to be extremely difficult. So you need to understand if your telescope is reversing the image or not, or if you're using a refractor, a reflector, it might be 180-degree rotation.
So
in which you might use the regular binocular map, but just flip it.
Yeah.
So I made these moon maps we have here for each Q day. They're based off of April this year, where the terminator location is, but the reflector, I think my brain's not working. One of them is flipped. I mirrored the image of the binocular view, and the other one is like flipped like this way, vertically. So you can find what type of telescope and view you have, and you'll be able to see each of the targets and where they'll be located on the moon for that type of telescope. We tried to make it easier for you. You can also rotate your book, but I decided to take some time to rotate it for everyone, because I should have clued in because I know optics, but I went to go look at the moon myself in preparation for this. And I was like, that doesn't look like the view I've been working on. Where is everything? And then I realized it was all flipped.
Yeah.
Well, you have an added complication. So I think my first observation with a little tabletop Dobsonian, and I was looking at it because I was leaning down and it was on the table. The Newtonian gives it a 180 rotation, but I was looking at the Dobsonian upside down. So it flipped it. The angle that my head was flipped it back, right?
Life hacks from John.
There's so there's added complexity there. But then for the rest of my observations, I use, and most, I think beginner telescopes, or at least most not very good telescopes, have an erecting eyepiece. And that one makes the view of the moon just like a binocular view. So it's as if you just took the regular view and made it bigger. So there's no rotation, there's no flip with most of these telescopes.
Recommendation for this week then, if you do not know what your telescope does, I know my telescope does this. It's a Schmidt-Cassegrain. If you don't know, go outside, even if there's no moon, even if you don't want to stay up until 2 a.m., even if you don't want to get up at 6 a.m., go outside and point your telescope at something and figure out what view you have. How many flippies there are, if it's vertical flippy or if it's like horizontal flippy. And then you'll be able to know which of these maps will work for you and just stick with that map type for the rest of the course. And you'll be all set.
Yep.
I'll throw out quickly just a plug that we do have workbooks for these. So these have all the instructions for each of the programs and logbook pages to write down all of your observations should you wish to purchase them. They are in the Rask store. There's one for binoculars and one for a small telescope. Each one is $10. And we have John's books too, which I have right here.
I have it on order. I ordered it today.
Minutes ago.
Just before this, I was like, I have to
Yeah.
get John's book.
And
So
John's,
these-
yeah, sorry, go ahead, John.
I could talk about it.
It's your book.
These books,
Yeah.
people love these books, and Dave Chapman was, instrumental in making this book a success. But if you observe everything in this book, you don't quite have enough targets for Explore the Moon. But this method of using this book to explore the moon is probably one of the most fun methods to explore the moon. And on every page, we've got all 3 targets that, based on the type of telescope you might be using, and then a zoomed in view of that target. So you know exactly what you're looking for. And what really makes that fun is it makes it effortless to find the targets. And this is organized by day as well. I didn't do Q days. I just did 1 to 14. But you also get the history of that crater. So all the craters are named after, famous scientists and people that contributed to the wealth of human knowledge. So you get the history of that person for whom the crater has received that namesake. So it makes it this to me is the most fun way to observe the moon.
Okay, John.
I mean, you're a little biased, but
Yeah.
This is science, yeah.
I mean, I thought it looked cool enough to spend my money on it. So,
John also has a workbook to go with it, which is the same workbook that if you did explore the moon, that you can sketch in as well. So that is available too.
So John's book's on Amazon, right? Because that's where I ordered mine. So is it on Prime or?
Yeah, you can order it at Amazon Prime or get it at Chapters, whatever. Chapters always runs out of it, or they always run out of inventory though. So
That's what happened to me. I tried to order it at Chapters because I had a gift card and it was out. But somebody was asking how long it takes to get to the far west coast. I'm sure John's book won't take that long. I don't know so much about Rask.
Rask books, we have one person who goes into the office to ship things out usually once or twice a week. And then it'll take the standard sort of like 6 to 10 business days to get there, I think. So 2 weeks-ish to get out. So they've been up on the website for a while, but we didn't advertise them very well. Sorry, everybody. So if you do want to buy them now, right now. And then you'll have them for like your second week of observing, hopefully, or second or third.
And you can just download a single page of our observation ones online and then just maybe staple it or something. And then
you can just glue it in on top. Yeah.
And so you can already start with the main pages that we use for observing.
And I'll just show you quickly that is right here. So these workbooks are here if you want to use them on that rask.ca/moon@noon. In both English and French, binocular and telescope. One last clarification, because there was a question. You can do it with binoculars, but if you do it with binoculars, they need to be fairly large and helps to be image stabilized. And you only get a certificate. You don't get the pin, and telescope gets you the pin. Then there's
the pin is valuable. We need the pin.
I made the mistake. Yes, the pin is what matters. It's bragging rights.
It actually holds my Tilly hat together.
Holds my ego together.
I just need I have a jean jacket. I just need more pins and patches on it.
Canadian
tuxedo.
Make a patch for this.
Yes.
So then here's all the books that are available to help you observe, some tips on sketching, some moon atlases, Dial a Moon, which we talked about, 3D Moon, which lets you see 3D photos, and LROC has a really great map of the entire moon as well.
I use Virtual Moon Atlas to create the moon maps that are right below. That one's interesting. If you have Windows, you can put in your like exact telescope eyepiece and stuff, and it will show you what you can see on that way. Unfortunately, you'll have to be kind of techie if you have Mac or Linux to be able to use it.
So that's why Samantha's made all these wonderful maps so that you don't have to use it if you're on Mac, which I am. Thank you, Samantha. So all the resources will be here. Your homework for this week is to get familiar with your telescope or your observing device, figure out what view works for you. And if you have the chance, go out and check out the moon. If you don't, take a look at the maps, get familiar with what you're going to be looking at. It really helps to get used to the moon and get used to what you're seeing. like I remember Samantha and I were talking about this earlier, being like, what's that crater? And I'd be like, oh yeah, that's whatever it is. And I was like, I didn't know I knew that. Like it was entirely because of like we looked at them on Explore the Universe. And so
Yeah.
that's
You definitely never will look at the moon the same way again after you know your way around, because it is a world with different places to visit and things to see, like mountains and seas and caverns and, you know, channels and whatnot. So you're going to be familiar with that and you're going to want to revisit it again and again.
Mhm. Or if you're like me, you're just going to look at the moon and be like, that's Q day -1 right now. I know. Waxing
Someone's
and
been
waning,
making
what
math.
is that? But I know the Q days.
Awesome. Okay, so we're gonna wrap this up by answering Paul's question, which is this on YouTube? Yes, everything will be on YouTube. Everything is on YouTube. It's live streamed to YouTube at the same time. Hello, YouTube family. We've not been paying attention to you. I'm sorry. I'm just gonna check. Oh, it's just Doug Fleming. Hey. So if you want to see them on YouTube, they will be there. They're rewatchable anytime. Dave says, yes, it is a lot to take in all at once. So feel free to rewatch this episode. And if not, we will see you in a week when we're going to be talking about, anyone know which Q day off the top of their head? Q day -5, which will be visible at the end of, right before our following observing session. So we will see you all on next Thursday, not Q day -5. We'll see you on Thursday next week at noon. Bring your lunch. And we'll be talking about Q day -5. Thanks everyone for joining. Samantha, John, any last words of inspiration for people?
I think we'll need to come up with a good sign-off catchphrase.
Yeah, because we have an intro
Yeah, so
video now.
that'll be our homework.
I would say good luck, but I'm saying good luck to myself as well, because we're all in this together.
Yep.
And Joanne, answering your question, we did set up a calendar that has all the Q days throughout this session. I haven't made it live yet. I need to double check and make sure that the observing nights are accurate. Once I double check and make sure they're accurate, that'll be up on our website as well. Good night and good luck. We'll see you guys next week.